Welcome to the Depth Dive. Today we're diving into network automation. It's really gone from, a niche thing to being absolutely essential.
Absolutely. It's changed so much.
Think of this as a quick way to get a handle on some key ideas, all drawn from practice questions for the JN0-422 exam.
Right. Good source material.
Yeah, so whether you're prepping for that cert or just trying to figure out what network automation is all about, or maybe you're just curious how modern networks actually run.
We're hoping to clear things up.
Exactly. Give you those aha moments. We'll look at tools, like Ansible, protocols like Netcon, and some specific Junos tech like PyEZ and Jet.
It's a good mix. It really shows how you need different tools for different jobs.
Okay, let's get into it then.
It's fascinating how it shifted. I mean, not long ago it was all manual CLI work, right?
Type.
And now the scale, the complexity.
Yay.
You just can't manage effectively without automation. It's about speed, getting it right every time.
Consistency, yeah. And making things more stable.
Exactly. Reliability.
Okay, so let's jump into our first concept, framed as a question. Which tool allows configuration management using playbooks and operates without an agent? Options are Puppet, Chef, Ansible, Jenkins.
Okay, that one's definitely Ansible. It's become really dominant in this area.
Ansible it is. So this agentless idea, it sounds technical, but what's the practical upshot? Why does it matter?
Well, think about it like this. Some tools, they need you to install a small piece of software, an agent, on every single device you want to manage.
Right, a little helper program.
Exactly. Ansible doesn't do that. It usually just connects using standard stuff like SSH.
Which network folks are already using anyway.
Pretty much, yeah.
Yeah.
So you skip that whole step of installing and updating agents everywhere. It just simplifies things.
Okay. And the playbooks.
The playbooks. They're basically instruction manuals written in this format called YAML. Really readable. They tell Ansible what configuration state you want on your devices.
So agentless means less setup, less ongoing work, and YAML playbooks make the instructions clear. Makes sense.
It really lowers the barrier to entry.
Okay, moving on. Question 2. What is the primary transport protocol used by Netcon for secure communication? Options: TLS, SSH, HTTP, Telnet.
For Netcon, the standard for secure transport is SSH.
SSH again. So security is key here, obviously. We're messing with network configs remotely. Why SSH for Netcon?
Well, Netcon is all about programmatically changing network device settings, right?
Yeah.
You absolutely need that communication channel to be secure. SSH provides two key things: encryption, so nobody can easily snoop on the commands or data.
Like scrambling the message.
Right. And authentication, which means both sides, the management system and the network device, prove they are who they say they are.
Got it. So it's a secure, verified handshake before any configuration happens. Makes sense.
Prevents unauthorized changes, which is critical.
Definitely. Okay, question 3. What is the main purpose of Junos PyEZ? Options are to replace the Junos CLI, to interact with Junos devices using a Python library, to run Ansible modules on the device, or to manage Junos devices via REST API.
The main purpose there is the second one, to interact with Junos devices using a Python library.
Junos PyEZ. PyEZ. So Python for Junos. How does that actually help someone doing network automation?
Exactly. Python's huge in automation generally, right? It's powerful, but also quite approachable.
Yeah, lots of people use it.
So Junos PyEZ is basically a toolkit, a library, that makes it easier for your Python scripts to talk to Juniper devices instead of manually typing CLI commands.
Like we used to.
Right. You write a Python script that uses PyEZ functions to, say, grab operational data or push configuration changes.
So it's like having pre-built Python commands specifically for Junos tasks.
That's a good way to put it. It really unlocks the ability to script more complex automation workflows beyond what maybe a simple playbook could do.
Okay, seems very powerful. Flexibility and efficiency boost. Now, question 4 is a bit more foundational Python. Which file is used in Python to mark a directory as a package? choices.main.py, config.py, setup.py, and init.py.
The double underscore file. It's init.py. That's the one.
Init.py. Okay, it looks tiny, maybe insignificant, but why does this matter for network automation specifically?
Well, it's fundamental to how you organize larger Python projects. I mean, imagine you're building a big automation system.
You wouldn't want just one giant script file.
Exactly. That init.py file tells Python, hey, this directory isn't just a folder, it's a package of related code modules. It lets you structure your code logically.
So you can group related functions together, reuse things.
Precisely. It makes your automation code cleaner, easier to manage, easier to share, easier to debug. Whether you're using PyEZ or anything else in Python for networks, good structure helps.
Right, bringing software development best practices into networking. Good stuff. Okay, question 5 circles back to Ansible. What is one benefit of using Ansible for network automation? Options. Requires an agent, uses a compiled language, provides agentless automation via SSH, only supports Juniper.
We've sort of hit this already, but the key benefit listed there is it provides agentless automation via SSH.
Yeah, seems like a core Ansible principle. Why emphasize this agentless part again? Well, what's the big deal for network gear specifically?
Well, network environments can be really diverse, right? Different vendors, different device types.
Hundreds, maybe thousands of devices.
Exactly. Installing and maintaining agents on all of those, it's a headache. It adds complexity, potential security issues, version management.
Ugh, yeah.
Ansible using SSH, it sidesteps all that. SSH is almost always already there on network devices for management. It's just simpler, lighter weight.
Less friction to get started and to manage long term. Okay, let's move to question 6. Which Juniper component enables high-speed programmatic access to the routing engine? Options. Netcon, JET, PEZ, SNMP.
That would be JET,
Yeah,
the Junos extension toolkit.
JET. Okay, sounds fast. High-speed programmatic access to the routing engine. What does that actually mean? Why would you need that kind of speed?
So the routing engine is like the device's central processor, making all the traffic forwarding decisions.
The brain, basically.
Pretty much. Now, things like Netcon for PyEZ interact with it, but JG provides a much more direct, low-level, high-performance connection. We're talking much lower latency APIs.
Okay, so it's for when you need really fast interaction.
Yeah, think about performance-critical stuff. Maybe you're building a custom application that needs to react instantly to network events, or you're collecting very fine-grained telemetry data, or doing sophisticated real-time traffic manipulation. JET is built for those kinds of demanding use cases.
Right, more specialized high-performance needs. Got it. Question 7 shifts back to formats. Which format is known for its readability and is often used in automation templates? Options. YAML, HTML, CSV, Bash.
That's definitely YAML. We mentioned it with Ansible playbooks.
YAML. It does look pretty clean, mostly indentation and colons. Why is readability such a big focus in automation?
Well, think about who uses these automation scripts and templates. It's often network engineers, maybe collaborating in teams.
Not always pure software developers.
Right. If the format is complex or cryptic, it's hard to understand, hard to write correctly, hard to troubleshoot. YAML is designed to be human-friendly. Simple structure, easy to scan.
So fewer mistakes, easier collaboration.
Exactly. It lowers the chance of errors and makes it much easier to maintain the automation code over time. Readability counts.
Makes total sense. Easier to read, easier to get right. Okay, question 8, back to netconning again. Which protocol is required for standard netconf communication? Options. HTTP, FTP, SSH, SNMP.
As we established, SSH is the one required for standard netcon.
Required, okay, so it's not just recommended, it's actually baked into the standard.
That's right. The standard itself mandates a secure transport, and SSH is the universally adopted way to meet that requirement for netconf. It ensures the integrity and confidentiality of the management session.
Good, security by default. Question 9, Ansible inventories. What is the purpose of an Ansible inventory file? Options. Install Junos updates, define groups of devices and connection details, store encrypted passwords, manage Jinja 2 templates.
The main purpose of the inventory file is the second option, to define groups of devices and their connection details.
Okay, so the inventory is basically Ansible's address book.
That's a great analogy, yeah. It's the list of what you want to manage. You list your servers, your routers, your switches, their IP addresses or names.
And you can group them, like web servers or core routers.
Exactly. Grouping is key. You can group by location, function, OS, type, whatever makes sense. And you can also specify how Ansible should connect to them, maybe a specific SSH user or port. It's fundamental for telling Ansible where to run the playbooks.
Got it. The who and how for your automation targets. All right, last question, number 10. Which statement accurately describes ephemeral configuration in Junos OS? Options. It's permanent and survives reboots. It logs commit history. It's used for dynamic temporary configurations. It replaces the traditional config hierarchy.
The accurate statement there is the third one. It is used for dynamic temporary configurations.
Ephemeral, like fleeting, right? Not permanent. What's the point of temporary config changes on a router?
Think of it like a scratch pad or a test environment, directly on the live device, but a safe one.
Okay, how so?
Ephemeral configurations allow you to load and activate changes without making them part of the main saved configuration. So you can test something out, maybe apply a temporary policy.
And if it breaks something or you just don't need it anymore?
If you reboot the device, that ephemeral config just vanishes. The device comes back up with its last saved permanent configuration. It's great for testing, for temporary troubleshooting filters, or applying dynamic policies that you don't want sticking around forever.
Ah, like a safety net for making changes. That sounds really useful.
It provides a lot of flexibility for dynamic adjustments without risking the stable base config.
So as you've listened to this deep dive, maybe think about this. How could understanding these concepts, maybe Ansible's approach or PyEZ, or even just the idea of ephemeral configs, how could that change how you look at network management?
Yeah, which of these tools or ideas feels most relevant to what you're doing or what you're interested in learning more about?
It's all about connecting these concepts to the real world, to your world. Thanks for joining us for this deep dive.